this. So today, we're going to do a different type of sequence. Yesterday we did the arithmetic, which means we were talking about, we're looking at a common difference between those two, right? So we looked at the sequence and we looked at the first term and the second term, and if they had a common difference, they had a difference. I wanted to make sure that that difference was the same for the second and the third and the fourth and the fifth, and so forth, right? So I checked out what the common difference was. I'm just going to give you the bare bones today because it's exactly going to be just like yesterday's, except we're talking about geometric sequences. With the geometric sequences, we're actually looking for a constant value as well, but the key here is not a difference, but a consistent ratio. It's going to be a consistent ratio. So let's go ahead and jump to that, identifying those sequences. Here we have a pattern. Goes 3, 6, 12, 24, 48. From 3 to 6, it's 3. From 6 to 12 is 6. I can already see that it's not the same, so it's not going to be arithmetic. So I'm going to try ratios. So I want to do n divided by a sub n. I want to try a sub n over a sub n minus 1, which means 6 divided by 3, that's 2. 12 divided by 6, that's 2. 24 divided by 12, that's 2. It looks like 48 divided by 24 is also 2. So I've got a constant ratio. Therefore, this sequence is geometric. And we're done. Okay? Questions? We're good? Now they do have a couple questions there. What is a sub 1 and what is r? Because if we were going to be doing some type of recursion or explicit, we need to know those. Of course, a sub 1 is our initial condition of 3, and our common ratio in this case is 2. Cool beans? All right, check out this sequence. Wait. Yeah.
So basically, we need to find the geometric sequence to divide the second one with the...
Yeah, you want to divide a sub n by the one before it. So it's kind of like going backwards, huh? Yeah, you go this divided by that, this divided by that, this divided by that, this divided by that. Okay? Can I change the slide? No?
Yeah.
Oh. All right, cool. So take a look at this sequence. Is this geometric? Well, what do? We check out those ratios. 6 over 3 is 2. 9 divided by 6 is 1.5.
No.
So no, I can stop there.
It's arithmetic.
It's arithmetic, isn't it? Because I can see that the only thing that's happening is it's going up by 3 every single time. That's constant, so it's arithmetic. Okay? The common difference is 3. So here we would say no, but we can still say a sub 1 is 3. But here we have a common difference of 3, not an r, but a lowercase d. Okay? Can I move on? Alrighty. How about this? You try it. Is it or is it not? It's not? Let's take a look. 3 to the 10th over 3 to the 5th ends up being 3 to the 5th. 3 to the 15th over 3 to the 10th ends up being 3 to the 5th. 3 to the 20th over 3 to the 15th ends up being 3 to the 5th. So do they have a common ratio? Yes. Touche. Sneaky one, that one, wasn't it? I just got a life. My life is worried too. That's funny.
You're going fast.
All right, can I switch the slide now? All right, I think you guys get the point there, right? Analyzing these sequences. So here I have a question. We've got a sequence that says 4, 12, 4, 12, 36, and they want to know what the 10th one is. Now, like I said before, let's see, what's happening from here to here? See, 12 divided by 3, 12 divided by 4 is 3, right? 36 divided by that is 3 also. So what's really happening to get to the next number? It's being multiplied by 3, right? The fastest way to get that, if this is all we're really after, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, is to take your last number in your calculator and then multiply by 3. Now what's really cool about calculators, it'll take the last answer in there and punch it in for you. So 36 times 3, that means I've got 108 times 3, blah, 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 blah. But, and we can sit there, we can do that. But you also want to get in the habit of practicing writing your formulas, your recursives and your explicits, okay? Because if the question comes up, hey, what's the formula for this then? You can't do much with it, right? So, like we just said a second ago, the recursive, super easy. Recursive, what is a sub 1? 4. And if I'm doing the formula, what's happening?
-1.
How are we getting the next number? We just said it a minute ago.
Times 3.
It just be multiplied by 3. So it's 3 times a sub n minus 1. And we're done. There's our recursive formula. So easy, yeah? So easy. Now, explicits are a little bit tougher. Ooh, got a little busy there. They always get a little bit tougher. So, what we need to do is we need to think about how the position number produces the answer. Because remember, recursive can only have, we can only have it in terms of n.
What is
10th R? No, that's 108. That was the number that we figured was supposed to go here. 108. And this is what I was telling you guys earlier that I tried to do. And it worked pretty cool for this one. So I went ahead and broke all those down because this is geometric. I went 2, 2. And then 12 gave me 2 times 6, 2 times 3. Then I got 36, which is 2 times 18, 2 times 9. And then that spat out 3 times 3. And then if you're looking at that, can you see a pattern emerging there? The 2's, huh? So if the next one is 108, which we've found, if I divide by 2, I get 54. If I divide by 2, I get, what is it, 27. Can I still divide by 2 here? No. But I can divide by 3. That gives me 9, 3, and then 3. Can you see the pattern emerging from here? It's easier to see it this way, isn't it? So with geometric, that should help. What's the formula going to be? Can you guys see it? Well, I always have that, don't I? Well, 2 times 2 is simply 4. Plus what? Actually, it shouldn't be 4. It should be 4 times, right? Because this is all being multiplied. 4 times what? Yeah, it's 3 to the n minus 1. It's 3 to the n minus 1. And there's your explicit formula. Can I change the slide? No, not yet. Not so bad, huh? It's getting hot. It's getting hot in here. Take off my sweater. I'm gonna fry. Trying to do a little cheer there. My name is Faith, and I'm so smart. I like to do my math all one day. No? No math? Never mind. It's all about math, though. Can I change the slide? Okay. What are the second and the third terms of this geometric sequence? What? Why do I have this one? Wait a minute. Am I missing a slide?
Maybe they're out of order.
Man. All right. Yesterday we talked about the arithmetic mean. The arithmetic mean was pretty simple, right? What do you do with the two numbers? One to the left, one to the right? Add them up, divide by 2. To find the geometric mean, you can't add them up, divide by 2, because obviously it's not like addition, right? It's not that type of operation. But what we're going to do is we're going to use what's called a geometric mean, blank 3. You still need the number to the right, you still need the number to the left. So, in this case, 48 and 3, and we're going to multiply them. We're going to multiply them. And once we do multiply them, then we'll take the square root of them. And that, my friends, is a geometric mean. The product of the left and the right, it's the square root of the product of the left and the right. Here, we'll call this, we'll give you a formula. We'll call this x, we'll call this y. The formula would be the square root of x times y. So in this case, it would be 12, right? Questions? Thumbs up, thumbs down? All right, that's good enough. Guys, I'm done for today. That's all I've got.